Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep unwinding after a long day, or simply looking for a quiet companion, you've found the right place. Before we begin, I'd love to know, where in the world are you listening from? Perhaps you're wrapped in a blanket sitting by a softly lit window or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into a distant cluster of galaxies where light moves like slow water and gravity writes its sentences without raising its voice. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who have already joined along, thank you. He sets the scene at a restful distance where redshift turns clocks into patient instruments, and what is nearby sight is far by time. Abell 85 sits in Cetus at Z0. No 55, a realm where hundreds of galaxies drift together in a shared halo of dark matter and hot gas. The fact is simple and sufficient. X-ray maps show a cool core nested in a wider, warmer atmosphere, a temperature gradient that betrays gentle inflow, and an old history of mergers now faded into order. The brightest member, Holm 15A, spreads a diffuse CD envelope so broad that its outskirts mingle with the intracluster light, a stellar tide of unbound tracers that wander like pale fish between islands of galaxies. In the hot medium metals heavier than helium trace past supernovae, a quiet enrichment that tells how star formation in many members salted the gas long before this night. In the radio age, electrons whisper along faint filaments where shocks once passed. In the optical orbits mix and round, and the cluster takes its slow breath. A lesser-known detail drifts through as a glint on that breath in the deep X-ray maps. A subtle discontinuity arcs near the core, a cold front that behaves like a contact between sloshing layers, evidence that even a tranquil cluster can remember a nudge from an infalling group for billions of years, the way a lake remembers a boat long after the wake has widened into nothing. Another small note sits in the starlight at the edges. The fraction of intracluster light grows toward the center and ebbs outward, a gradient of unbound stars that memorializes the frequency of tidal encounters near the heart. Each unpinned red giant becomes a tracer, not of one galaxy but of the cluster's whole potential. He lets a soft mystery remain in view without asking it to decide anything. How quiet the core truly is, whether the central engine in Holm 15A sits in a long low feast or in a cycle of brief cooling regulated sips, whether the inner light profile shows a genuine depleted core scoured by past black hole binaries, or only a shallow cusp blurred by the way diffuse starlight is modelled. These are questions that different instruments answer in slightly different dialects, leaving a corridor of uncertainty that is more informative than a verdict. Dry observations place themselves where they will not disturb the surface. They call the cluster relaxed, yet substructure survives in the outskirts, knots and filaments still arriving along a several megaparsec spine that feeds the potential with small groups. Relaxation here is not an end state, but a rate. They call the core cool, yet the gas is still tens of millions of degrees only cool when compared to the cluster's hotter shell. Language shrinks its shoulders and lets the thermometer speak. They call the central galaxy single, yet CD envelopes remember many bodies' dry mergers layered into a continent of diffuse light so that one name stands for many endings. The imagery stays elemental so that the scale remains breathable. Gas is the slow river of X-ray brightness pooling luminous entropy in broad eddies. Dust is faint and local, but carries the colour of old stars in CD outskirts. Light behaves like weather scattered by tiny motions into spectra that encode velocity dispersions and temperatures. dark matter is the wide basin that sets the banks and leaves no direct mark but shape. A gentle analogy has room for one short breath. The cluster is a highland marsh, where streams gather and move without haste, each channel carrying faint leaf litter from earlier rain. The central lake is deep and cold at the bottom, and the surface stays unruffled even when long memories glide under it. The accepted fact placed once expands into quiet consequences that need no emphasis. In a cool core system, the central temperature dips and the pressure profile steepens. Hydrostatic equilibrium approximates the mass in shells. Metallicity peaks toward the center evidence of many supernovae, in many small histories depositing iron and oxygen into gas that forgets names but keeps elements. Faint radio knots, if present, speak of feedback that slows runaway cooling without needing flame or flare. Cavities left by old bubbles can buoy outward like dark lanterns, transferring energy to the medium with the gentlest insistence. Around this, the galaxy population arranges itself by the cluster's slow virtues. Quenched ellipticals crowd the core. Star-forming disks prefer the outskirts where ram pressure has not yet bitten away their gas. Jellyfish morphologies appear here and there, stripped drawstrings of star-forming knots along tails that keep their blue, even as the parent galaxy reddens a passing detail that confirms the medium's thin, steady wind. He lets three soft ironies find their places. Only took billions of years of violent merging to make a place that now looks like rest. Only required temperatures that would melt any matter on Earth to be called cool, because physics refuses human adjectives and asks only for ratios. Only needed a black hole beyond imagination at the center to produce almost no visible fireworks, a giant that eats slowly, because the city around it is pouring gas. He returns to the central light not to weigh it yet, but to note its calm grammar. Holm 15A's envelope declines gently, more like a shallow shoreline than a cliff. The inner light can be modelled by different functions. Cora Cercic multi-component or a Cercic with a modest inner change of slope, and each function carries implications about what black hole binaries did or did not remove from the centre. Spectra across the core gather hundreds of thousands of faint photons into velocity dispersions that thicken toward the middle. These dispersions are not a portrait but a fingerprint, and they will in later sections become orbits, and those orbits will become a mass. For now, he leaves a second, smaller mystery resting beside the first, whether the sphere of influence is large enough to be fully resolved at this distance, and under which assumptions about anisotropy. Whether light and motion can be reconciled by a single set of stars, or whether a dark component bends the fit just so. The cluster continues to breathe while the question sits. At larger radii, the intra-cluster gas tells a measured tale. Entropy profiles bend where cooling and feedback have negotiated terms. Shock edges from older infall wash out into ripples. Abundance gradients smooth under mixing, without flattening to zero. The potential deepens into the outskirts where filaments join, and those joints appear as small temperature teeth in the radial plots that observers love, and the sky does not know it makes. The CD envelope meets this medium without fuss stars that once belonged to other galaxies, now stroll unconcerned through potentials they did not start in. Intracluster light takes on the gradient of the whole, pointing not back to a parent but down the basin. Three more dry observations step lightly into place. They call individuals by names, yet most of what is seen belongs to ensembles, halos, populations, distributions. Names keep memory, but gravity keeps averages. They call distances far, yet redshift turns them into a scale as practical as any ruler. For the cluster Z055 is simply a coordinate, not a milestone. They call the X-ray background empty, and yet its faint mottling carries everything the gas would say if it had a voice. He resists any tug toward plot and keeps the tone flat and clear. Abell 85 sits, light crosses, gas holds heat and metals, stars roam and sometimes are unpinned. The centre remains calm, not because there is nothing to do but because most of the work was done long ago when the cluster was younger and louder. The presence of a central giant black hole is an inference that begins here as a premise of structure galaxies this large, with dispersions this high and cores this shallow, almost always host central masses that scale with their bulges. Outliers exist and Holm 15a will be weighed, but the scale itself is a quiet law with generous scatter. For this first step it is enough to let the basin be a basin, the core be cool, the envelope be broad, and the intracluster light be a slow tide in which many sources have already dissolved. He closes the section by returning without summary to touch each element once like stones along a path. Fact: a cool core cluster at a modest redshift holds a seedy galaxy with a vast envelope inside a metal-rich halo of X-ray gas. Detail: a cold front arcs near the centre, a sloshing edge that remembers a small disturbance without asking for any more. Mystery how depleted the central light truly is, and how the unseen mass makes itself legible at this distance. Irony's violence makes calm. Hot is called cool. The largest engine is nearly silent. The image lingers stone-coloured galaxies in a dim inland sea, gas like warm dusk, and in the quietest place of all a horizon too small to see and too heavy to ignore. He lets one galaxy fill the frame until its light becomes more like weather than a lamp, because the central giant of Abell 85 Holm 15a spreads a continent of stars so gradually that edges lose their meaning. The accepted fact stands in the middle without asking. This is a seedy galaxy, a brightest cluster giant whose diffuse stellar envelope reaches far into intracluster space. A shallow slope of starlight that departs from ordinary bulge laws and merges with the cluster's own tide. Its profile declines like a shoreline after flood, not a cliff. Isophotas stretch and twist gently with radius. The outer halos grow boxy and then round again as orbits mix. The light is old and red, dominated by stars whose fuel dwindled long ago, and yet the surface brightness remains detectable to hundreds of kiloparsecs when integrated patiently. A dim geography mapped by hours and algorithms rather than by eyes. Around it, the intracluster medium glows in X-rays, and the peak of that glow sits close to the galaxy's core, a quiet coincidence that repeats in cluster after cluster. The place where the gas rests deepest is usually where a CD has taken its seat. A lesser-known detail rests like a faint watermark near the outskirts at radii, where the night is effectively empty to human sight. The isophotas still carry a small twist, only a few degrees across tens of kiloparsecs, hinting that the envelope remembers the directions from which cannibalized companions once approached. The twist is not a headline, only a residue of history preserved in geometry. Inward, the light becomes almost featureless, as if the galaxy's memory had been sanded smooth by many dry mergers. Outward, fine ripples and low-contrast plumes linger at the edge of detectability remnants of tidal streams that have nearly dissolved into the intracluster sea. He sets the giant into its room by the forces that made it. Dry gas poor mergers add stars with little new gas to ignite growing size faster than mass and building a shallow outer slope. The stellar debris of swallowed satellites drifts outward into the envelope, and some of it drifts farther still, becoming intracluster light that no longer belongs to any single galaxy. Dynamical friction brings heavy companions to the centre. Their stars stay. Their dark matter joins the cluster's reservoir. Their git, if any remains, is stripped by the hot medium before it can light new blue. Repetition replaces revolution. Orbital families pile into a round average when seen from afar, but the details never quite forget boxy isophotes, where radial orbits leave their mark, faint shells where a merger's timing was just so, diffuse CD plumes aligned not by law but by habit with the directions from which infalling groups have most often arrived. The giant eats slowly now because it lives where the pantry is hot and thin. There is little cold gas for spectacular accretion, and the central engine, whatever its mass, sits beneath a city of stars that can only fade. He leaves a quiet mystery unforced at the core, because the centre is where models disagree by inches that matter. Whether the inner light holds a genuinely depleted core carved by the slingshot of black hole binaries ejecting stars, or whether the apparent shallowness is a projection of a diffuse starlight and orbit anisotropy remains a corridor rather than a room. Photometric fits choose between core Sersic and multi-component grammars, while kinematic maps try to decide whether an unseen mass demands a stronger sentence. Even when the sphere of influence is large in models, its observability at this distance is a discipline of seeing not what is bright, but what is consistent velocity dispersions that rise or flatten higher-order moments that betray a preference for radial or tangential motion. The verdict is ultramassive either way. The precise adjective waits on orbits. Dry observations take their places like flat stones you can cross without getting wet. They call Holm 15A one galaxy, yet its envelope is made from hundreds, maybe thousands of unbound stars that no longer remember a parent by name. Unity is a convenience, not a genealogy. They call its light smooth, yet the smoothness is the sum of innumerable scars, each too faint to own a contour. They call it central, and it is, but the centre is defined by gravity's patient average, not by a pin. The galaxy's photometric heart and the cluster's potential minimum often coincide within a few kiloparsecs and occasionally do not a slosh so small that only maps, not moods, can notice. He keeps the imagery elemental so the scale can be held. Starlight is silt carried far from its delta, settling in layers too thin to see but thick enough to weigh. Dark matter is the basin that accepts silt without ever changing colour. Hot gas is dusk held in place by pressure tense, luminous, and incapable of cooling quickly without help. The galaxy itself is a slow delta of orbits pouring into still water. After many floods, the channels blur, and the land becomes a low plain that reaches beyond the eye. A gentle analogy breathes once and leaves Holm 15A is like an inland sea after a long thaw. Shorelines recede and expose shelves. Old rivers spill new sand onto flats already made of older sand. The whole scene looks quiet because the clock ticks only for those who watch rivers, not for those who remember glaciers. He returns to small telling craft because this giant is read by methods more than by eyes. Sky subtraction is a ceremony, not a checkbox to measure an envelope. This faint observers must know the night itself as a number. Misjudge the sky and the envelope shrinks or swells as by imagination rather than by stars. Masking faint companions and stacking deep frames keeps tidal wisps from being mistaken for background ripples. Modelling the inner light with more than one component prevents a single function from becoming a story. Cross-checking with kinematics disciplines fancies that photometry alone might allow. The result is not a portrait, but a ledger written in residuals where fits fail physics speaks. 3 soft ironies place themselves along the ledger's edge. Only took a century of refining how to subtract darkness to discover that the largest galaxies are half made of what subtraction reveals. Only required hundreds of forgotten mergers for the light to become nearly featureless, so that smoothness is not simplicity but accumulation. Only needed the hottest, most barren environment in the cluster's heart to preserve the most delicate architecture, an envelope of stars that would have been stirred and reignited into chaos if cold gas had been plentiful. He sits with the central engine without raising his voice. A black hole of uncommon scale likely waits in the nucleus, but the accretion it manages in a gas-poor, pressure-rich city is sub-Eddington and subdued. Radio jets, if present, are faint. X-ray point sources are modest against the halo. Any cavities they inflate in the intracluster medium are small compared to the hothouse lanterns seen in wilder cores. Feedback here acts like a thermostat, not a siren enough to keep the coolest gas from cascading, not enough to light the room. The galaxy's luminosity-weighted age lies high. Its metallicity tells of many past generations. Its A-element ratios remember rapid star formation long ago. Now only an occasional minor merger, or the slow rain of stars from disrupted satellites increases the envelope by 1% here, and 1% there the way a shoreline inches outward when the river is weary. He lets a second, quieter mystery remain at the rim. How distinct the envelope is from intracluster light, whether there is a physical break where belonging ends and drifting begins, or only a convention set by isophotal slopes stays a matter of taste guided by thresholds. In simulations, stars unbind gradually, in data profiles bend, in discourse labels catch up to gradients. The cluster does not mind which word is chosen, only the counts care. The giant's relation to the filamentary geography beyond the core enters without needing a preface. Abell 85 connects to the cosmic web through channels of infall, and the CD's faint plumes tend to line up with the directions groups most often arrive from a statistical preference, not a rule. On those lanes, satellites fall lose their gas to ram pressure before they cross the last few hundred kiloparsecs and reach the inner potential carrying stars alone. Those stars land softly, layering the envelope without ripple big enough to shout. An observer who stacks many clusters sees alignments in the round. An observer who studies one sees patience. 3 more dry observations find their places near the close. They call this galaxy brightest, yet much of its light per unit area is fainter than the background once was before modern cameras learned to hold still. They call the core scoured, yet even a depleted centre can be the densest place for hundreds of kiloparsecs around. Emptiness here is relative to an abundance that is otherwise unimaginable. They call the envelope extended, yet extended is a word that tries to capture hundreds of kiloparsecs with a syllable. The scale belongs to the cluster, not to the dictionary. He settles the section where the giant simply is large enough to be a background for its own details. The fact remains where he set it. Holm 15A is a CD galaxy whose diffuse envelope blends into the intracluster light, a brightest cluster system built by dry mergers and long mixing. The lesser detail keeps its seat. A small persistent twist in outer isophotes preserves a memory of approach directions long after the streamers have faded. The mystery stays with its proper patience, whether the inner light is truly depleted by black hole scouring or only appears so under certain grammars, and where, if anywhere, the envelope ends and the cluster begins. The ironies lie quiet, subtraction reveals substance. Violence produces smoothness, poverty of gas preserves grace. He leaves the giant as a lantern that does not flicker, a basin of orbits whose edges are not edges, but habits, and a centre where whatever mass waits does so without hurry, because the city around it has already done most of its changing, and now prefers to be read, not revised. He turns the light inward, until brightness becomes an argument with itself, because at the centre of Holm 15A, the choice of grammar changes the meaning of silence. The accepted fact sits in the middle without posture. The inner surface brightness profile measured across arcseconds that translate to kiloparsecs at this distance is shallow enough that some analyses read a depleted core where stars are missing relative to an inward extrapolation, while other analyses using different functional forms and point spread treatments recover a gentler cusp without a deficit at all. A few steps of method decide whether a hole in starlight is carved, or only sketched by assumption. the galaxy endures either way. He keeps the craft visible so the center can be read as work rather than outcome. In deep images, the sky is subtracted to a precision that would embarrass any candle. Isophotes are fit ellipticity and position angle allowed to breathe with radius. Nuclei and foreground intruders are masked, and then the inner light is modelled. A single Cerseic law curvature controlled by its index often fails in the centre. A core Cerseic grafts a shallow inner power law onto an outer Cerseic, turning a bend into a break. A Nuka function built from two power laws with a smooth join can mimic many shapes, but has no asymptotic promise at great radii. Multi-component fits stacking Cerseic-like pieces let inner and outer envelopes speak different dialects. Each choice Kakao carries priors suppose a single population with a single curvature and a deficit looks decisive. Allow a diffuse CD envelope to contribute light even at small radii, and the deficit shrinks or dissolves. Convolve with the telescope's point spread function carefully, and a cusp steepens from a blur into a slope. Neglect the PSF wings or the diffuse envelope and the core grows by imagination. A lesser-known detail threads the argument with a calibration all its own. The inner profile's slope depends not only on seeing and depth, but also on scattered light from the enormous outer envelope. Even at tens of arcseconds or out, faint wings of the PSF can fold background starlight back into the nucleus and flatten or steepen the measured curve unless those wings are measured with bright stars and deconvolved with patience. A function that fits numbers well is not yet a physics. Only when the convolution, the sky, and the neighbours are disciplined does the centre consent to be described. He lets a quiet mystery remain uncorrected, because it is the right size. If a true depleted core exists, it is the fossil of black hole binary scouring after dry mergers. Two central holes sink form a binary, and through three-body encounters fling stars on radial orbits, outward excavating a light deficit whose break radius can reach kiloparsecs in extreme cases. If no deficit exists, the same shallowness may be the superposition of orbit families in a galaxy grown by many dry mergers with tangential anisotropy, masking any ejector. Which is it here? Carved deficit or gentle cusp depends on fits that good minds make with different emphases. The centre's truth may be both some ejection long ago, then refilled by stars from later minor mergers, leaving a profile that refuses extremes. Dry observations seat themselves where shoes will not scuff them. They call a core a subtractive idea, yet subtraction depends on what one first decides to extrapolate. Missing compared to which parent is not a property of the child. They call the break radius a measure of violence, yet breaks move when the fit's outer radius moves. Violence here has error bars that can widen or narrow with a choice. They call the innermost slope a signature, yet slopes read differently in ground-based seeing and space-based sharpness, and agreement is an achievement not a given. He keeps the imagery elemental so argument stays gentle. The inner light is silt-stirred by old winds thin enough to show the basin's floor to methods, but not to eyes. The missing light, if missing, would be sand thrown outward by a pair of stones spinning in the riverbed. Grains resettle downstream into the envelope where observation calls them smoothness. The cusp, if cusp, would be a gentle shoal where currents have not quite stopped arriving, a proof that carving did not outrun refill. The numbers beneath the imagery hold to quiet scales. Central surface brightness measured in faint magnitudes per square arc. Second declines inward more slowly than a steep Cerseic would expect. Elliptical isophotes retain only modest twists. Colour profiles show little blue light that might betray recent star formation. And higher-order kinematic moments, if measured, offer hints about anisotropy. A positive H4 can mean tangential bias that hides a deficit's kinematic tell. A negative H4 can whisper radial orbits whose depletion a binary might have caused. He lets one gentle analogy pass and then sit reading. This centre is like reading a palimpsest with a magnifying glass whose lens you must polish yourself. Scrape too hard and you destroy the later text. Polish too little and the earlier text smears into the present. Both stories need to be legible at once. The argument touches mass without yet weighing it because grammar and gravity are not independent. If the inner light truly turns down relative to outer expectation orbit-based dynamical models, may prefer a heavier central mass to account for high dispersions in the absence of high central starlight. If the inner light is simply shallow but continuous, the same dispersions can be matched with less central mass and different anisotropy. Here, small photometric bends trade against large dynamical nouns. The sphere of influence defined where the black hole's gravity outweighs the stars can be large in model space and still be only partly resolved in data. A radius of influence that spans a kiloparsec in physical units becomes a few arcseconds on the sky, competing with seeing PSF and the spread of diffuse envelope light. At such scales, even honest measurements invite honest differences. He sets 3 soft ironies where they cannot trip anyone. Only took adding one function to another to turn a carved void into a shallow hill, reminding him that profiles are opinions until kinematics are invited. Only required the faintest per pixel brightness in an envelope, hundreds of kiloparsecs wide to influence the shape of the innermost arcsecond's outer light that edits inner truth. Only needed a process as violent as a black hole binary to leave an absence that modern instruments can argue out of existence with a different convolution. He returns to the merged city that could have made either shape. In a gas-poor cluster core dry, mergers dominate stars and gas seldom cools. Binaries form scour, and when stalling threatens are nudged by triaxiality, centrophilic orbits or a third black hole from a later merger. Slingshot ejection removes stars on plunging paths and the distribution function tilts toward tangentially biased orbits that can sustain a shallow profile without new stars. If later, minor mergers rain stars onto the centre, they refill some of what was removed, smoothing the deficit into a cusp. If not, the break endures. Observationally, the two end states can differ by subtleties in both light and motion. At this distance and with this envelope, subtleties are a discipline, not a promise. A quieter, precise detail sits near the page's edge, even when images are sharp-fitting. The inner light demands a local sky estimate, not contaminated by CD wings, which may require measuring the night far from the galaxy and transporting that estimate inward under control of gradients. Small sky errors translate into large ratio changes in the inner fit, not because the centre is dim, but because the profile's curvature is inferred from contrasts, not absolutes. The palimpsest metaphor returns uninvited and is allowed to stay. He lets kinematics enter only as foreshadowing, because orbits are the tool that will later weigh the mass that grammar debates. Integral field spectroscopy maps velocity's dispersion across the face, and anisotropy hides in the fourth moments. Orbit superposition models libraries of paths in a trial potential try combinations until the map is matched. The black hole mass stellar mass to light ratio, and if allowed a dark halo's inner pull trade likelihoods until a shallow minimum sits quietly between models. If a depleted core exists, the orbit library must account for missing radial paths. If no deficit exists, the library can populate both radial and tangential families with more freedom. Either way, the fit is not a vote, but a balance. 3 more dry observations walk to the margin. They call the central deficit evidence for a giant black hole, yet giants also live beneath cusps. Evidence is a tapestry, not a single thread. They call the kinematic rise decisive, yet rises flatten when PSF and templates are revised. Decisiveness is a property of residuals behaving not of a slope's colour. They call the conclusion final, yet new data deeper or sharper reset the priors without asking permission. the galaxy does not mind being looked at twice. He refuses summary and instead lays the pieces back down where they began. The accepted fact holds Holm 15A's inner light is shallow. Some grammars write this as a depleted core, others as a gentle cusp within a multi-component structure. The lesser technical detail holds PSF wings from the outer envelope can bias the inner slope unless measured and deconvolved with care. The mystery remains, did black hole scouring carve a true deficit that later received a little refill, or has a long history of dry mergers simply left a shallow equilibrium that never lost light in the first place? The ironies rest where they were placed. Assumptions make deficits. Outer faintness edits inner truth. Violence leaves quiet questions. He leaves the centre as a surface whose shape is both what stars did and what methods allow a soft floor, whose curve will in later sections be read together with motion so that grammar and gravity can be reconciled without raising any voice. He lets motion become measure, because in a galaxy without fireworks, gravity speaks most clearly in the small changes of starlight speed. The accepted fact rests in the centre without ornament, orbit-based dynamical models built from libraries of stellar paths and tuned to match two-dimensional maps of line-of-sight velocities translate the flicker of a Doppler shifts across Holm 15A's face into a mass for the unseen object at its heart. Light becomes kinematics. Kinematics becomes gravity. Gravity returns as a number with patient uncertainties. He keeps the craft visible so the weighing can be felt as method rather than verdict. Integral field spectroscopy gathers spectra in thousands of tiny tiles across the galaxy, each tile a narrow window on the summed light of many old stars. The spectra are cleaned, sky-subtracted, and binned with Voronoi tessellations until each region reaches a target signal to noise. Template libraries stars observed with the same instrument are combined to match absorption features. From the fits come the mean line-of-sight velocity, the dispersion and higher moments H and H4 that betray skew and kurtosis in the velocity distributions. These maps are the fingerprints the model must learn to reproduce. Beneath them sits the mass model, a luminous component built from the observed light, and an assumed stellar mass-to-light ratio. A dark matter halo with a shape and scale that the fit can loosen or tighten, and at the centre a point mass that has no spectrum but sets a boundary condition on orbits drawn too near. The orbit library is wide prograde and retrograde loops, boxy wanderers that approach the centre tube families that skirt it, paths fanned through radii and inclinations. Each orbit's time average contribution to each pixel is tabulated under the gravitational potential defined by trial parameters. The model then chooses non-negative weights for these orbits to match the observed light, and the observed kinematics regularize so that neighbouring orbits in integral space do not jump without reason. If a black hole is too light, the model cannot lift the central dispersion without overfilling the core with radial orbits that would spoil H4. If the hole is too heavy, the model raises dispersion too much, unless it populates tangential orbits that distort the outer fields. The preferred mass lies where the mismatch is smallest and smoothest, the bottom of H2 valley that takes its shape from data and assumptions both. A lesser-known detail travels quietly with these steps because the galaxy's stars are bright and old. A small number of luminous giants can dominate certain tiles and bias dispersions upward by shot noise. To blunt this, observers mask or mitigate spaxels where individual bright stars skew the statistics or they fold in statistical corrections derived from the luminosity function, keeping the maps honest to the ensemble, rather than to a few elders who shout. Another modest point sits beside it, instrument-specific issues, such as line spread function variations across the field slicer seams in the integral field unit, or tiny spectral flexures with temperature are tracked and corrected, because at this distance small systemic over or under broadening of lines can masquerade as gravity. He leaves an appropriate mystery in the room because weights are precise but priors are pliant. How much the central mass depends on a gradient in the stellar mass-to-light ratio. Older, more metal-rich populations toward the centre, making mass denser than light implies remains a live degree of freedom. Allow ML to rise inward and less black hole mass is needed to lift dispersions. Hold ML constant and the point mass grows to shoulder the load. Triaxiality is another corridor. If the galaxy's figure departs from axisymmetry, certain orbit families become more or less available, shifting the best mass within the same photometry. Add the dark halo's inner pull and the valley broadens again. Reduce it and the valley narrows. Each assumption is defensible. Together they become the width of the answer. Dry observations sit down where they can be stepped over without catching a toe. They call the mass a measure of a point, yet the point is inferred from motions across kiloparsecs, not from lighter location. The sphere of influence may span only a few arcseconds on the sky, and still the centre sets conditions far out. They call the fit decisive, yet confidence intervals live and breathe, with choices about ML gradients, halo priors, and orbit regularization. Decisiveness is a property of a valley's curvature, not of a headline. They call the black hole ultramassive, and it is by any scale, yet the nucleus remains quiet because gas is scarce. Mass is not brightness here, only curvature in phase space. He keeps the imagery elemental so the equations can rest. The orbit library is a net thrown across a slow river of stars. Each thread of the net is a possible path, and the weight assigned to that thread is how often that path is walked. The unseen mass is the stone under the river that bends the flow near the middle. The mass-to-light ratio is the density of water beneath the ripples. The dark halo is the shape of the riverbed. When the model lowers the stone, the current near the centre slows and fails to match the observed swirls. When the model raises the stone, the current brightens too sharply, unless the net is warped to hide tangles. Somewhere between without fuss, the river's map fits. He lets a gentle modern analogy have one quiet breath. Orbit's superposition is like arranging a choir, where each voice sings a pure tone. By choosing how loud each singer is, and the conductor makes the harmonic that matches the recording. The black hole is the constraint that certain high notes cannot be reached without adding stronger bass. The practical arithmetic insists on its presence too, because methods are the way this weight becomes less a story and more a number. The light model comes from deprojecting a measured surface brightness into 3 dimensions under an assumed symmetry. Deprojection is non-unique for flattened systems, so priors on inclination on axis, ratios anchor it. The point spread function is measured from stars and used to blur model predictions before they meet data. Template mismatch is explored by repeating fits with different stellar libraries. Sky subtraction is checked with off-target fields because faint wings and scattered light from the CD envelope can otherwise bias central dispersions. Regularization, if too strong, strips the library of flexibility and forces smoothness that the galaxy does not prefer. If too weak, the model memorizes noise. The preferred middle is found by cross-validation on mock data that share the instrument's sins but not the galaxy's secrets. 3 soft ironies settle in like small stones on the rim of the map. Only took millions of numerically integrated orbits to measure an object that does not move. Only required assigning weights to paths, no star names for the sum of unnamed motions to reveal a single nameless mass. Only needed to resolve a few arcseconds of kinematics to weigh a horizon whose radius, even scaled by billions, remains smaller than the thickness of the smallest contour the eye can see. He returns to the bridge between light grammar and orbit ledger laid in the previous section, because reconciliation, not replacement, is the discipline here. If the inner light truly shows a deficit, The orbit library naturally shies away from strongly radial paths in the center and prefers tangential families that keep dispersions high without a spike in H4. If the center is a shallow cusp with no deficit, the library is free to mix. Either way, the best fit black hole mass absorbs the difference. The same star counts if assigned a rising ML inward can lift central weight, without demanding a larger point mass. If ML is held flat, the point mass takes the lift. Data that tie ML, such as color and line index gradients calibrated to population synthesis, narrow this trade. Where such constraints are modest, the valley stays broad. A quieter detail sits with the subtlety it deserves. The rotation field in Holm 15A is low, so the models work mostly with dispersions and their moments. In rotating systems, H3V anti-correlations are strong anchors. Here, H4 becomes the better whisperer of anisotropy, and H4 is delicate to measure because it lives in the wings of absorption lines that sky residuals and template choice like to touch. The models hear a quiet instrument and must not pretend it is loud. He allows the sphere of influence to pass through as an idea whose size is both reassuring and humbling. Defined where the black hole's gravity matches the star's dispersion support, the radius is physically large. Hundreds of parsecs to a kiloparsec for ultramassive candidates, yet at this distance it maps to angles that seeing and PSF still test. That it is resolved in some datasets means only that some part of that radius yields a detectably higher dispersion or a pattern in H4 consistent with central pull. It does not promise that every systematic has relented. Dry observations resume their walk. They call chi-squared a truth teller, yet H2 responds to error bars as much as to physics. Shrink uncertainties too far and models fight phantom precision. Widen them and veils flatten until every mass seems allowed. They call regularization a technicality, yet how tightly neighbouring orbits are tied together controls how rough the model may be in matching small kinematic wrinkles. Roughness can lower H2 by memorizing noise which is not a victory. They call the dark halo negligible in the core, and often it is yet removing it entirely can force the stellar ML to carry dynamics it does not own. Balance, not erasure, is the calm choice. He does not give a number because the script prefers the way of the weighing to the digit of the weight, but he lets the scales sense settle. The preferred masses for Holm 15A under reasonable assumptions sit in the realm of tens of billions of suns ultramassive by any standard, with ranges that narrow or widen with choices about ML gradients, halo shapes and anisotropy. The result is not caprice but sensitivity to qualities the data cannot fully fix from this distance. Newer instruments with finer sampling and quieter systematics walk the valley's floor more slowly and find its lowest point a little lighter than earlier fits that lacked such control. Either it erases the other, because the valley is a geography mapped by many travellers who took different paths. Three last ironies lie down where they will be noticed only if asked for. Only took a galaxy made almost entirely of old stars, no bursts, no bars, no strong rotation to produce the cleanest laboratory, and still leave uncertainties because cleanliness magnifies the importance of every remaining assumption. Only required a cluster whose gas is hot and thin to keep the nucleus dim enough that the mass must be weighed by Leibniz, not light. Only needed an engine beyond imagination to make gravity the gentlest statistician, a curvature in motions measured in tens of kilometers per second against a background of hundreds. He lets the weighing exhale without outcome rhetoric. The fact has done its work. Orbit-based dynamics turn kinematic maps into a mass for the unseen centre. The lesser detail keeps its place-shot noise from a few giants, and the minutiae of instrumental line-spread functions can bias dispersions unless handled with care. The mystery remains correct in size, how ML gradients, triaxiality and halo choices trade with the black hole mass. where along that trade the real galaxy sits. The ironies rest. Light continues to move, orbits continue to be summed, the net continues to be thrown over the same slow river. The stone beneath continues to bend the flow without ever needing to rise to the surface. He stays with the number because the number wanders and its drift says more about craft than about doubt. The accepted fact sits quietly at the center early orbit-based fits to Holm 15A's kinematics built on the deep integral field spectroscopy, and a luminous model without strong gradients in stellar mass-to-light ratio favoured a central mass near 4 times 10 to the 10th suns. Later analyses with finer spatial sampling, revised instrument models and allowances for mild Abell gradients and different anisotropy settled nearer 2-point-something times 10 to the 10th. 1 engine, 2 weighings, both ultramassive, the valley of H2 narrowing and shifting as priors learn manners. He keeps the differences in the open so the number can breathe. In the first weighing, the library of orbits worked against a luminous mass scaled uniformly by a single ml, and the point spread function reconstructed carefully but still a limit blurred the central rise in dispersion. To lift that rise without overpopulating radial orbits that would have betrayed themselves in H4, the model leaned on a heavier point mass. In the second weighing kinematic tiles closer to the centre, a quieter line spread function, and a population-informed likelihood for ML that climbs a little inward, allowed the luminous mass to carry more weight in the core. The orbit library then found a solution with a lighter point mass and a touch more tangential anisotropy, still heavy, still rare, and now resting in a narrower, better mapped valley. A lesser known detail sits beside these steps like a small instrument on a large stage. Even the choice of spectral region calcium triplet versus magnesium and iron lines nudges dispersions by a few kilometers per second when template mismatch is not perfectly tamed. Those few kilometers multiplied across thousands of spaxels and anchored to a seeing disk that is only a few times the sphere of influence lean the mass by fractions that in this regime are counted in billions of suns. The sky does not change, the number learns to listen. He lets the uncertainty remain a corridor rather than a hole. How much inward gradient in Mel is realistic for an old metal-rich population? How triaxial the figure is under a smooth envelope? How strong the dark halo's pull is even at these radii? And how generously to regularize orbit weights so the model remembers physics rather than noise. Each is a dial that moves the best fit mass by a shoulder's width without moving it out of the class. The verdict is not a coin flip, it is a balance beam that different hands zero with slightly different standards and the same discipline. Dry observations settle where they belong. They call the revision a retreat, yet the later weight sits well inside the earlier uncertainties when the same priors are rerun on the newer data. What looks like backtracking is often only a camera sharpening its focus. They call the first mass an outlier, yet outliers are how scaling relations learn their range, and an ultramassive point near a shallow core in a CD is exactly where theory allows extreme growth. They call the difference dramatic, yet in log space astronomy's natural language, half a dex is a step along a footpath, not a cliff. He keeps the imagery elemental so the statistics can rest. The number is a depth sounded by echo. The first shout returns with one interval, the second shout cleaner and closer to the wall returns with another. Both echo the same basin, and the difference belongs to air angle and the thickness of the fog. The mass is a stone beneath a slow river. One survey draws its outline by how fast the surface moves near the centre. Another, with the stick that reaches little deeper, feels a contour the first could not. The river does not mind that 2 sketches of the same stone differ by a hand's breadth. He lets a gentle analogy take one breath and stop the weighing. It's like tuning a piano in a quiet house. The first tuner sets A by a fork and leaves a trace of stretch at the top. The second brings an electronic reference and softens the stretch. Both leave a playable instrument. The difference is in the overtones, not in the song. The reasons for ultra-massive weight do not need embellishment, so he places them once and lets them rest. Dry mergers pile stars into CD centers without gas to cool. Black hole binaries harden and expel stars on radial paths, building either a deficit or a shallow cusp. Successive minor mergers refill smooth and tilt anisotropy toward tangential. The sphere of influence grows into kiloparsec scales. Velocity dispersions remain high while rotation stays low. Scaling relations, MS, ML and their cousins predict large masses for such dispersions and envelopes with scatters that welcome bold points. Holm 15 fits this ecology. Whether the black hole is 40 billion suns or 22 in the ledger, the physical story does not turn. A quieter detail keeps the company with the ecology. The same datasets that weigh the point mass also recover a stellar ML consistent with old A-enhanced populations. Slight colour and line index gradients map the mild ML climb inward that later fits a Lau. The photometry that once seemed only a canvas for dynamics returns as a constraint that curbs the freedom of the orbit library to lean too hard on the point. When pieces speak together, numbers stop needing to be loud. He sets 3 soft ironies where they can be noticed without raising any pulse. Only took changing a prior by a gentle slope in ML to move billions of suns from the black hole into the stars and leave the galaxy looking exactly the same. Only required instruments to calm their own line spread function by a few % for a mass that dwarfs globular clusters to step down by a fraction and become more certain. Only needed the absence of gas and light, no bright AGN, no blue starburst to force gravity to be measured by silence and to teach that silence is precise when listened to closely. He acknowledges the sphere of influence because it is where the two weighings meet. Defined by RSOIGM S2, the radius for either mass sits in the few hundred parsec to kiloparsec regime. At Abell 85's distance, that is a handful of arc seconds comparable to seeing for ground-based data and less demanding, but still delicate for space-based imaging. The first fit with coarser sampling and broader PSF resolved the sphere of influence in the statistical sense, but fought convolution. The second with tighter sampling and an empirically tracked PSF resolved more of it and leaned less on assumptions. Neither claims a direct image of a ring at RSOE. Both claim that the kinematics inside this angle refuse to be matched without a heavy centre. He leaves a modest mystery in the corner of the room because future instruments always rearrange furniture. How much a traxial, slowly tumbling figure would alter the orbit census in the core? Whether a faint, unresolved nuclear component in light an ancient star cluster remnant, or a compact stellar population could slightly bias deprojection. How deeply a chord versus cuspy dark halo matters within the central kiloparsec. These are avenues where answers shift second decimals without shifting classes. The mass remains ultramassive. The error bars remain honest. The reasons remain ecological rather than exceptional. Dry observations resume their walk. They call a heavier mass impressive and a lighter mass conservative, yet both owe their adjectives to context impressive relative to earlier maxima, conservative relative to priors that now include gradients. They call the second result a correction of the first, yet the better word is B'ningmen, the early value guided attention and instrument time to a difficult target. The later value spent that attention on systematics that matter. They call the range confusing, yet a range that narrows under new data is the shape of understanding, not its failure. He keeps the scene grounded with one more concrete, unhurried detail. The nucleus that holds either weight remains sub-Eddington by large factors. Accretion luminosity in X-ray and radio stays low. Any feedback it provides to the cool core is gentle, perhaps intermittent, and certainly insufficient to write bright cavities like those in fiercer clusters. The mass is not a lamp, it is a lens in phase space. The cluster's gas cools slowly under a thermostat. Stars in the envelope age. Intracluster light drifts. The horizon in the middle keeps its absolute smallness against the immensity of the CD's face. 3 final ironies lie down at the edge like pebbles that do not disturb the water. Only took the quietest galaxy centre for methods to shout at each other and then lower their voices together. Only required fewer free electrons in the core, less gas, less glow for gravity to be weighed better, not worse. Only needed 2 answers, both enormous, for the truth to be that the difference matters to papers and leaves the sky unmoved. He lets the number sit without ceremony. The accepted fact has done its work early fits favoured, 4 by 1010 solar masses. Later fits favour 2 by 1010, 3 by 1010, depending on gradients and geometry. Both declare an ultramassive engine consistent with the CD, built by dry mergers in a cool core cluster. The lesser detail keeps its chair small spectroscopic choices, and PSF wings can lean dispersions by kilometres per second that become billions of suns unless tamed. The mystery stays the right size, gradients, triaxiality, halo pull, and anisotropy trade in a valley whose floor is now better mapped. The ironies remain where they were placed. The stone under the river stays heavy. The river passes. The map improves and never needs to become a verdict to be useful. He lets scale turn into a kind of weather because the same mass writes 2 different skies, one near, one far. The accepted fact rests at the centre without display, a black hole sphere of influence defined roughly by SOIGM. It's 2 marks where its gravity outweighs the random motions of surrounding stars, and for an ultramassive engine in Holm 15A, that radius reaches hundreds of parsecs to about a kiloparsec, while the event horizon itself, RS2GM, remains smaller than the solar system by many orders, an absolute circle too small to see against a face larger than many galaxies. 2 radii, 1 body, a difference so wide it makes measurement feel like listening to thunder and watching dust at once. He puts numbers into air and keeps them quiet. Take a mass in the low tens of billions of suns and a central velocity dispersion of a few hundred kilometers per second. Then RC lives at scales the model can in principle resolve with careful seeing, good sampling and patient deconvolution. The horizon, by contrast, is measured in light hours to light days, an arc so tiny at the cluster's distance that it would challenge any conceivable eye. The lesser-known detail arrives like a glint in that disparity. The light crossing time of the horizon, even for a mass this large, is minutes to hours, but the timescale for stars to respond across Rasui is millions of years. The same object contains a clock that ticks faster than weather, and a clock that ticks slower than continents, and instruments must choose which kind of time they know how to keep. He lets geometry become feeling without leaving science. Inside, ROI orbits arc more tightly. Tangential families can carry high dispersion without raising higher-order moments too much. Radial families near the centre betray themselves if overused. The library of orbits weighs this balance until kinematics and photometry agree. Far beyond RSOI, the mass still matters in principle, but the galaxy's stars and dark halo share the burden, and the influence becomes a slope in the background rather than a bend in the middle. At the same time, the event horizon is a boundary where light itself must turn. If one could zoom down the kiloparsec stare in a single unbroken view, the last step would be a precipice beyond which time changes its grammar. But here that precipice is a number imposed on a model of motions that never approach it. The quiet mystery stays proper in size. Whether RSOI is truly resolved depends not only on angular resolution and sampling, but also on what the galaxy allows its anisotropy, its ML gradient, its deprojection. Even with exquisite data, one model's sphere can be another model's suggestion if priors lean differently. Yet across those leanings, the necessity of a heavy centre persists. The horizon does not negotiate. Our view of it does. Dry observations take their seats where they do not disturb the river. They call the sphere of influence large, and it is in parsecs, yet on the sky it fills only a few arc, seconds a width, easily bruised by seeing and by PSF wings, from the very envelope the black hole helped to build. They call the horizon unimaginably big, and it is in mass, yet as an angle, it is negligibly small, smaller than any dust speck on an optical mirror, so that the greatest engine in the cluster hides by being perfectly black and perfectly tiny. They call resolving the core a victory, yet resolution in this work is a statistic. No ring is seen, only patterns in line widths and line shapes that integrate many stars' decades of orbits into a shape a model can grasp. He keeps the imagery elemental so the two skies can be held together. The sphere is a weather map of motion isobars, of dispersion bending inward, wind roses of anisotropy changing subtly with radius, a pressure field of light and mass balancing into curves. The horizon is a coastline that cannot be walked, only inferred from tides the faintest perturbation in the current, felt far from shore. Put both into one sentence, the stone under the slow river is big enough to lift the channel near the middle, and small enough that no one will ever see its surface, only the water tells its shape. He allows one gentle analogy and leaves it where it rests. Soir is like the hinterland of a city, the distance at which street plans begin to point toward the centre. RS is the courthouse square, a place most citizens never visit, and whose outline you know because all the streets converge in maps rather than in sight. He touches timescales again, because time is the way scale often explains itself. Dynamical times near RSOI are 10 million years and up, so the dispersion that observers measure tonight encodes the memory of orbits they will not live to see complete. By contrast, even a small flare at the horizon would play out in hours, but with so little gas in the nucleus there is almost nothing to flare. The city is quiet. The courthouse clock goes undine. The suburbs, not the square, draw the map. He leaves 3 soft ironies like flat stones. Only took gravity that bends space-time into a knot to leave its best signature not where light stops, but where aggregate starlight looks a little wider or a little narrower in a spectrograph. Only required the radius where the black hole matters most dynamically to be thousands of times larger than the radius where it matters absolutely, so that the measurable influence is the lesser boundary, not the ultimate one. Only needed a mass beyond imagination to be weighed by features smaller than a pixel spread over thousands of pixels, with the answer emerging only after subtraction teaches itself to be patient. He returns to the relationship between influence and core shape because it is where grammar and gravity share a table. If central light is shallow by scouring or by superposition, the sphere of influence can look large in kinematics without an obvious photometric cusp. If later minor mergers refill some of what a binary removed, the mass still requires a broader SOE, but the profile reads as a cusp that never left. In both cases, anisotropy steps in to carry part of the signature tangential bias. Near the centre is a common echo of scouring, and a small positive h4 away from the very centre becomes a modest telling foothold for models that must choose. Our SOI then is not a circle in an image, but a region in phase space where particular orbit families begin to be necessary rather than optional. A quieter precise detail sits on the rim because the CD envelope is so extended, and the PSF's outer wing so influential light from radii well outside RSOI scatters into the inner tiles. This contamination, unless measured and deconvolved, suppresses perceived gradients in dispersion across the sphere's edge, shrinking the signature the models need. The outer light thus masks the inner mass unless the night itself is counted with millimagnitude honesty. The influence of the horizon on its environment is modest too, and he keeps it modest. Sub-Eddington accretion in a gas-poor core gives jets and bubbles, if any, that are faint and small. The Bondi radius, where hot gas feels central pull to accrete, is much smaller than RSOI and lives in a medium already warm by the cluster's pressure. Feedback here is a low thermostat, not a storm. The black hole matters enormously to orbits and little to light. The cluster's gas notices its presence only through the long arithmetic of equilibrium, not through fireworks. Dry observations continue their walk. They call RSOI a threshold, yet thresholds in galaxies are slopes, not steps. No orbit knows a line. Maps impose one to speak. They call the horizon a singularity, yet the singularity is a calculus point. What matters observationally is the photon sphere, and the last stable orbit, both irrelevant at this distance because no telescope can bring them near. They call influence power, and it is, but it is also responsibility to keep dispersions high where stars are few, and to make anisotropy calm rather than theatrical. He touches the cluster once more because the city changes slowly around the square. In time, more satellites fall on dry orbits. Their stars add to the envelope and barely touch the centre. The sphere of influence inches outward in model space as total mass grows and stays high. The horizon's physical size grows imperceptibly unless rare gas arrives. Even then, growth is logarithmic on human diagrams, large numbers that change only by patience. If the cluster's cool core remains stable, the nucleus remains dim. If the core sloshes and little gas slips inward, the radio can brighten briefly and then fade, leaving the kinematics unchanged. 3 last ironies settle near the close. Only took an environment nearly devoid of cold gas to give the cleanest dynamical signature of an object that was forged in collision-rich epochs long past. Only required the faintest, broadest envelope to be the biggest systematic in measuring the sharpest, smallest thing a PSF wing writing over a horizon. Only needed a radius of influence big enough to touch many orbits for the best evidence of a horizon to come from places where that horizon is not even a rumour, only a line in an equation. He lets the section rest where numbers and images become one habit. The factors stood RSOI for Holm. 15A's central mass reaches to scales models can read in kinematics, while the horizon is far below any image. Both belong to the same object and to different crafts. The lesser detail remains clocks at the horizon tick in hours, while the sphere's kinship with stars ticks in millions of years. One is too fast to matter here, the other too slow to notice, and instruments split the difference by counting light. The mystery stays at its proper weight resolution. Anisotropy and ML gradients decide how cleanly SOI is seen, not whether a heavy centre exists. The ironies keep their quiet. The lantern in the cluster breathes with the stone in its throat that no eye can see and every map can feel, and the river that flows over it does so without foam, patient as starlight. He lingers where aftermath becomes architecture, because the mass at the centre is less a monument than the residue of many quiet meetings. The accepted fact sits calmly in the middle brightest cluster galaxies like Holm 15A. Grow, primarily through repeated gas-poor dry mergers after their early star formation. Peaks adding stars without lighting new blue, expanding their outer envelopes faster than their inner densities and leaving behind shallow central profiles where black hole binaries have shuffled or ejected stars on radial paths. Dynamical friction draws heavy companions inward over many crossing times. Ram pressure and tide strip satellites of their remaining gas before arrival. When the cores finally meet, their central black holes form a bound pair and harden, transferring energy to stars that wander too near and sending those stars outward into the CD's diffuse skin, or all the way into the intra-cluster light. The debris from these repeated events is what looks like smoothness. Now, the same way many ripples become a calm when time is allowed to pass. A lesser-known detail lays a faint watermark across this calm, the outermost plumes and shells that dry mergers leave behind glow at surface brightnesses fainter than 28 or 29 magnitudes per square arc, second places where even modern cameras must stack hours and tame the night to see them. When such wisps are mapped around seed galaxies, their preferred orientations often align statistically with nearby filaments of the cosmic web, as if the rare survivors of dissolution still remember the lanes along which their parents once fell. In Holm 15A, the envelope appears nearly featureless, yet small twists in isophotos and low-contrast asymmetries whisper that the history was directional even if the result is round. He lets the growth sequence remain unhurried so its logic can be felt. Early in the cluster's life, stars are forged in denser progenitors. Later, as the intra-cluster medium heats and cool cores stabilize, cold gas becomes scarce in the center, and the infalling supply dries up. What remains abundant are satellites whose stars are old red and bound. Dynamical friction slows them. Tidal forces unbind their outskirts first. Their central light, when it finally arrives, deposits itself gently. With each dry merger size, grows more than mass scaling, like a slow tide that spreads farther with every cup poured in. The velocity dispersion at large radii stays high because the cluster's gravity does not flag. Rotation stays modest because the arriving orbits are mixed. The outer profile takes on a shallow slope, a statement not of laziness but of arithmetic that stars are added at large radii faster than they can diffuse inward. At the very centre, black hole binaries do work that starlight alone could not. After a merger, the two holes sink to the nucleus and bind. Stars with orbits that cross the pair's sphere of influence are flung outward, carrying away energy and angular momentum. The binary hardens. The central distribution function tilts toward tangential orbits that can graze the pair without being expelled, and the light either turns down relative to an outer extrapolation or flattens into a shallow cusp that owes as much to refill by later accretions as to the excavation itself. If a third merger arrives before the pair coalesces, a new three-body dance can drive one hole out and tighten the remaining pair further. If coalescence completes a gravitational wave recoil, can kick the remnant by hundreds of kilometers per second, carving briefly coalesce, a wandering core before dynamical friction recenters it, events too fast and small compared to kinematic maps to be seen here, yet honest residents of the ledger that dry growth keeps. A quiet mystery stays seated without asking to be solved. Whether the central shallowness in Holm 15A is a true deficit left by repeated scouring later, softened by a refill, or a long-lived equilibrium of orbit families assembled by dry accretion without a substantial missing mass episode. Both paths are plausible under similar initial conditions. Both produce high dispersions and low rotation. Both leave outer envelopes that look like weather smoothed by time. The discriminant's minute differences in higher-order moments, faint colour or line index gradients, delicate signatures of tangential anisotropy live at the edge of present data where PSF wings from the vast envelope and population gradients in ML make judgments into ranges. Dry observations set themselves down like flat stones. They call these growth events major and minor, yet the galaxy does not count the same way. Many minors can mimic a few majors in their effect on size while adding less to the centre, and labels are a habit of catalogues, not of the stars. They call the debris fine structure, yet Most of it dissolves within a few dynamical times into the envelope, so that absence of feathers is not absence of history, but proof of patience. They call the central binary efficient, yet even efficient scouring is bounded by the supply of centrophilic orbits. Without triaxiality or fresh stars to scatter, a binary can stall, and the next merger must help. Efficiency here is a sequence, not a single act. He keeps the imagery elemental so that arithmetic can breathe. Dry mergings, sand added to a shoal by a calm river grains land on the outer bars. Bars spread, the channel's depth near the middle scarcely changes, though the cross-section grows. Once in a while, two heavy stones meet in the current's throat and push pebbles to the sides, making a slight hollow that later floods partway again when a long rain delivers more sand. The galaxy's envelope is the shoal, the central binary, the stones and the intracluster light, the sand that drifts past the banks into the marsh beyond the river. A gentle modern analogy is allowed. One breath, the growth resembles an urban core that gentrifies by absorption rather than new construction. No cranes, only buildings bought and blended into larger block streets, widening while the courthouse square stays the same size. The lesser-known details continue to place themselves where they add quiet texture. In stellar populations, A-element enhancements in CD centers speak of short, intense star formation epochs long ago, with Type II supernovae dominating yields. Toward larger radii, metallicity gradients flatten as accreted stars, typically less enriched, mix in. In kinematics, H4 profiles that ease upwards slightly at small radii are the modest fingerprints of tangential bias left by past ejections. In light, the transition from galaxy-bound stars to intracluster light is not a step, but a slow change in slope, and attempts to name a boundary mostly reveal the convenience of names. These threads together explain why Holm 15A looks old and yet grew late. Most of its stars formed early, but the shape we now see Psi's envelope core was sculpted by assembling those stars in place after the forging cooled. 3 soft ironies settle without drawing attention. Only took dozens of nearly gasless encounters, each so undramatic that no one would have noticed one by itself, to build a galaxy whose outline dwarfs entire groups. Only required scouring by black hole pairs violent enough to fling stars at escape to produce the quietest possible core, where the best evidence is a slope so bland it can be modelled 2 ways. Only needed a history spent almost entirely without cold gas to preserve the most delicate architecture, an envelope that would have been disturbed again and again had blue bursts kept arriving. He keeps the role of the cluster's medium in view because the room itself acts as editor. The hot intracluster gas strips satellites, quickly ending star formation on their way in, so the CD accretes mostly red systems that enrich the envelope without feeding the nucleus. The same hot medium imposes the slow, steady pressure that prevents cooling flows from piling cold clouds into the center, so the black hole accretes at a low rate, and feedback remains a thermostat rather than a cyclone. Ram pressure tails from late infall become part of the intracluster light instead of the CD's disk that never was. In this environment, dry mergers are not an option, but a policy the room enforces. A second quiet mystery remains at the outskirts. The fraction of the CD's light that belongs to intracluster tides rather than bound orbits is measured by deep images with sophisticated sky subtraction, yet the exact dividing line moves with method. Some studies tie the threshold to a change in ellipticity or to a kink in the profile, others to kinematic evidence from planetary nebulae or globular clusters that follow the cluster rather than the galaxy. Holm 15A's smooth face offers few discrete traces at this depth. What the analysis chooses to call envelope or ICL changes the counted mass by a few tens of %, while leaving the physics the same. Dry observations continue their walk. They call the CD a cannibal, yet cannibalism suggests a drama that dryness denies. This is not devouring, but composting. Satellites are laid into the soil of an envelope that grows. They call the core a deficit, yet deficits are measured against fits, and fits are opinions disciplined by convolution. The core is what remains after arithmetic, not a whole one can point to with a finger. They call the central mass a cause, yet it is also a consequence. Binaries need mergers. Mergers need a room that supplies them. The mass is a ledger entry made by many hands. He turns briefly to theory because models learn the same patience the data require. Simulations of cluster assembly show that brightest cluster galaxies gain a large fraction of their outer mass after redshift 1 through dry accretion. Their effective radii grow by factors of few while their central densities evolve little. Repeated dissipationless mergers drive profiles toward shallow outer slopes, and when black holes are included, toward flatter centers. Triaxiality keeps loss cones fit so binaries do not stall prematurely. Occasional three-body interactions speed coalescence. Gravitational wave recoil kicks are usually insufficient to eject remnants from deep cluster cores, but can leave wandering imprints that fade. None of these results demands a single striking event. All of them prefer a long, gentle rain. 3 final ironies lie down near the close like pebbles in a low tide. Only took adding darkness, no gas, no bursts to write the brightest, widest light into a map people can measure. Only required the very processes that erase features phase mixing and violent relaxation to produce the subtlest features, which then become the only clues left. Only needed a history spread over billions of years to create a present so even that it seems simple until arithmetic refuses to reduce it. He lets the section rest where growth becomes a habit rather than a headline. The accepted fact has done its work. Holm 15A's mass and shape are the cumulative result of dry mergers that enlarge the envelope and black hole binaries that rearrange or remove central stars. The lesser detail keeps its place. The faintest plumes and shells aligned statistically with the directions of arrival and live at brightness levels that demand patience to see. The mysteries stay proper carved core versus shallow cusp with refill, and the exact division between envelope and intracluster light. The ironies remain still. The cluster's room continues to supply red companions at a pace that does not hurry. The envelope continues to smooth, the nucleus continues to weigh by silence, and the city of stars continues to be built by what it has already become, a place where aftermath is the principal architect. He turns to the air between the islands because the cluster's slow weather holds the record of how everything arrived. The accepted fact sits in the middle. Without effort, Abell 85 is a cool core cluster, its intracluster medium warmer on the outskirts and gently cooler toward the center. A stratified lantern of X-ray gas where temperature, density and metallicity each curve inward with their own quiet grammar. Pressure stays nearly hydrostatic when averaged in shells. Entropy falls toward the nucleus like a slope that flattens near the bottom. Iron abundance rises in the inner tens of kiloparsecs as if a memory of internal supernovae had settled there and never left. Around that calm, patterns interrupt themselves with soft authority, a cold front outlined like a blade of glass where cooler, denser gas glides past warmer layers without mixing, and on another flank a discontinuity whose brightness, jump and temperature rise together, speak the language of a long-faded shock. Sloshing spirals inward as a phase-wrapped wave, a fossil of a small group's past intrusion. Deprojected profiles catch its ripples as deviations that never shout. The lesser-known detail is a spectroscopist's whisper that floats through the lantern central abundance peaks sharpened when resonance. Scattering is accounted for photons in strong iron lines redistributed out of our view by a Modest optical depth so that neglecting the effect can smear the peak into a plateau and make the core seem less enriched than it is. The correction is small. The consequence gentle and still. It reminds him that even light in a thin plasma can choose another path on its way to the mirror. He keeps the geometry elemental so the scale does not slip. X-ray brightness is the square of electron density integrated along the line of sight so the center glows, not because it is hot, but because it is full. Temperature maps read like gently painted topography, coolest in the inner basin, and stippled with patches where substructure has brushed past. Pressure maps multiplied from density and temperature smooth into rounder cups. Entropy proportional to KTN E to 2, 3 becomes the map that most plainly displays the history of being stirred power law in the outskirts where infall heats and mixes, flattening toward a core that cooling once tried to dent and feedback later held up. He lets feedback enter without ceremony. The central engine in the Holm 15A is quiet by human standards and still enough to matter in arithmetic. Radio knots, if present, are small. Cavities, if any, are subtle. Yet the absence of a catastrophic cooling flow. No vast lake of rapidly condensing gas. No cascade of new blue stars means that heating weak and persistent has balanced losses for a long while. In the ledger conduction across small scales, turbulence from sloshing and gentle AGN outbursts share the work. None dominates, all are patient. The quiet mystery stays measured and honest how the budget closes each epoch. What fraction of cooling is arrested by weak frequent puffs from the nucleus? What fraction is offset by mixing and the small shocks that sloshing drives? How much conduction can leak heat from warmer layers into the core without being strangled by magnetic insulation remains a set of ranges that maps approach from different sides. Metallicity profiles sharpen with better background control and line modelling. Temperature substructure hardens or softens as deprojection improves. The balance remains a conversation rather than an answer. Dry observations take their seats where they cannot be tripped over. They call it a cool core, yet temperatures everywhere would vaporize rock. Cool here is a comparison, not a climate. They call the gas smooth, yet smoothness is the average of many faint scars. Ram pressure wakes behind infalling galaxies' edges, where a group scrape the medium and filaments where stripped gas still shines until it dissolves. They call the center calm, yet the pressure there bears the weight of a cluster. A calm like the bottom of a deep lake that looks flat because the water above it carries the load. He lets infall right itself in simple strokes. Groups approach along the filament that feeds Abell 85 as they fall their own gas bows backward under ram pressure and peels away into long wakes that heat mix and eventually disappear. The galaxies inside those groups enter the core bleached of fuel. Their star formation already dim their contribution to the cluster's light, now only stellar and red. A shock from such an episode departs like a ring. By the time it reaches the scale of hundreds of kiloparsecs, it is only a temperature step a little higher on one side than the other. A brightening so mild it needs subtraction to be seen. Sloshing begins when the core is nudged off-center. Like a basin of warm soup, set down too quickly, it traces a spiral of alternating cool and warm layers that circle inward. At each contact, Kelvin Helmholtz billows try to grow, sometimes suppressed by the magnetic draping that aligns field lines with the interface and hardens it against shear. The result is an edge that is sharper than pure fluid would allow and softer than a wall. The central enrichment tells its own quiet story. Over billions of years, Type-Ear supernovae in the central galaxy have salted the nearby gas with iron. Earlier, more rapid star formation added A elements. The peak of metals near the nucleus broadened slightly by mixing sharpens again, if uptake by cooling is modest. Diffusion is slow. Advection by sloshing spreads peaks into arcs. Across it all, the inner tens of kiloparsecs remain richer than the outskirts. A chemical gravity that observers have learned to trust even when the geometry leans. A gentle analogy is allowed one breath and then is left alone. The cool core is like a cellar in late summer, cooler than the house above, lined with jars that remember earlier harvests and kept from becoming a freezer by a slow exchange of air and occasional opening of the door. He returns to quantities because they keep the cellar true. Central electron densities climb to tenths per cubic centimetre. Cooling time in the innermost shells fall below a giga-year. At radii of a few hundred kiloparsecs, the entropy follows the familiar nearly power law rise. The mass profile implied by pressure gradients agrees with that inferred from galaxy kinematics within generous errors that maps deserve. In some annuli, the temperature steps up by a factor of order unity across a narrow arc. A cold front when density rises and temperature falls, a shock when both rise. The Mach number for the latter, if identified, lives in the regime of gentle persuasion rather than violence. None of these facts demand a headline. Together they draw a room that still remembers being furnished. The lesser-known detail returns with the craft of seeing because X-ray maps look straightforward and are not. Backgrounds in detectors drift with time. Soft protons masquerade as real sky. Blank sky fields differ in particle noise. Abundance determinations near one key rely on complicated blends in iron L-shell emission that need careful atomic data. Small errors in column density along the line of sight tilt temperature fits. Observers build mosaics across the field mass point sources and compare deprojected and projected fits, then cross-check with Sunyaev-Zeldovich pressure constraints where available. What emerges as a cold front or a shock has passed through a sieve of corrections. The fact that it remains is the measure of its reality. 3 soft ironies settle into the bench. Only took gas so hot that it does not cool quickly to preserve the sharpest cold edges in the map. Only required a core stable enough to avoid catastrophe for billions of years to carry the marks of small disturbances longer than any tide on Earth. Only needed the absence of a luminous central flare for the balance between cooling and heating to become visible as a steady account book instead of a spectacle. He lets galaxies interact with this weather because they leave signatures the gas then keeps. Spirals that venture too far inward become jellyfish narrow tails of star-forming knots, blazing in blue for a short distance before fading to nothing, each knot stitched into the wake by ram pressure and sheared by the wind. Ellipticals contribute little but mass and light. Dwarfs dissolve into the background and thicken intracluster light. The medium, by stripping and heating, builds the decorum of the core, redder members close to the centre, bluer ones farther out, and between them a quiet transition where gas has just been taken and stars have not yet dimmed. The quiet mystery returns to the thermostat that refuses to show its hand. If the nucleus puffs in weak, frequent radio breaths, how far do their waves travel in this density and field? How much turbulence do they seed before viscosity and magnetic tension turn eddies into heat? How deeply do sound waves penetrate before their energy becomes part of the entropy profile? And on what schedule do these processes occur? The answers appear in simulations as ranges and in observations as absences of catastrophe. The book balances because the core persists, not because any single line item dominates. Dry observations continue their walk. They call sloshing a perturbation, yet it is a long-lived arrangement that sets where cold fronts rest for ages. They call shocks transient, yet their imprints on the temperature field can outlast the galaxies that launched them. They call abundance peak central, yet the stars that made those metals now span half the CD's diameter, and the peak belongs as much to orbits as to explosions. He lets the section close where weather becomes habit rather than event. Abell 85's gas holds a cool core. and a warm memory edges where layers slide steps, where a wave once crossed a cellar of higher iron and lower entropy that speaks of many small burnings and many small stirrings. The accepted fact remains where he put it. A stratified intracluster medium cooler in the centre contains substructure cold fronts, weak shocks and sloshing spirals that record infall and stripping. The lesser detail keeps its place resonance scattering, and atomic subtleties can blur or sharpen central abundance peaks unless faced directly. The mystery rests at its scale. What share of the budget belongs to weak feedback? What share to mixing and conduction, and how the shares change with time? The ironies lie still cool means tens of millions of degrees. Calm is made from disturbances. The best evidence for balance is the lack of spectacle. The lantern of gas continues to glow like dusk held in a bowl patient in its arithmetic content to let galaxies come and go, while it writes their passage into heat edges and metal without ever raising its voice. He turns from hot dusk to dim starlight that barely remembers who sent it because the intracluster light is the cluster's softest weather. The accepted fact rests in the centre without asking to be noticed. Unbound stars drift between galaxies in Abell 85, forming a diffuse glow whose surface brightness thins below 28 to 30. Magnitudes per square arc, second, and whose fraction grows toward the cluster's core, a tidal tide that swells where encounters are common and ebbs toward the outskirts. These stars are not attached to any one island. They are the foam left when orbits cross, satellites dissolve, and dry mergers stir gently rather than spill. Their colours lean red because most were born long ago and lost their gas early. Their metallicities lie between those of massive ellipticals and dwarfs, a mid-tone that fits the arithmetic of stripping and pre-processing in groups before arrival. They move in the cluster's potential, not in any single galaxy's grip, and in doing so they draw the basin's shape in a light so thin that seeing it is an act of subtraction and patience. A lesser-known detail glides in with them like a faint tracer at the edge of vision. Planetary nebulae. In the cluster's outskirts, tiny green coins to the eye in nearby systems become near invisible. Here, yet specialized surveys still catch a few, and their velocities show that past a certain radius many no longer follow a brightest galaxy's kinematics but float with the cluster's dispersion. These rare points anchor a conclusion that deep imaging implies the intracluster light is a separate choir humming in the key of the cluster, not the solo of the CD. He keeps the craft visible because maps made of little are easily bent by much. Measuring such faint light means drilling down through night itself. Ski backgrounds must be modelled across the field and across time. Scattered light from bright stars must be measured far into their wings. Detector flatness must be trusted in the domain where a fraction of a percent becomes a horizon. Once the canvas is even, the profile emerges as a slope that breaks slowly. Not all at once one component that fits a galaxy's inner body, another that handles its extended envelope, a third that flattens into a radius where the cluster takes credit. Whether the break is phrased as a profile kink, a change in ellipticity, or a turn in the gradient depends on method, not on the sky. He sets the formation in motion without making it a story. Galaxies arrive along a filament. Groups fall and are unstitched. Dwarfs shed stars, first spirals lose their outer disk next, and even sturdy spheroids surrender halos when tides and harassment add up over orbits. Encounters in the core are mostly fast and glancing. They heat and stir more than they merge. Over time, the unbound debris accumulates into a component with its own symmetry, flatter near the CD where orbits pile rounder, farther out where the cluster's shape wins. The intracluster light gains mass by dozens of unceremonious events, strips, splashes and dissolves that leave no headline and all the evidence. He lets a quiet mystery remain with its proper scale, where to place the boundary between a CD envelope and the intracluster light when both lie along the same line of sight and both were built by the same weather. Kinematics helps where traces exist. Surface brightness breaks help where they do not. Population gradients sometimes tip the balance. Yet any division carries taste, and different teams working honestly will count differently by tens of %. For the physics, the range is enough more unbound starlight toward the centre, less toward the rim. A component that grows with cluster age. A colour that remembers old quenching and gentle mixing. Dry observations sit down like flat stones that do not tilt. They call this sea smooth, yet its smoothness is the sum of 1,000 dissolved streams. Every curve began as a feather and a ripple. They call these stars lost, yet they keep the cluster's shape more faithfully than many bound galaxies that are still finishing their fall. Loss becomes a better map. They call the component faint, and it is per unit area, yet integrated over hundreds of kiloparsecs the light rivals large galaxies. Faintness here is spread, not lack. He keeps the imagery elemental so thin brightness can be held without slipping. The intracluster light is dust in evening air, visible only when the sun is low and the angle is exact. It is silt carried beyond the river delta, spreading so wide that no single channel claims it. It is the low fog that gathers in hollows every night, not made by any one field, but owned by the valley. A gentle modern analogy has one breath and passes the component is like the light of a city seen from far above. Individual streets merge into glow, and yet the grid, the river and the hill all still shape the haze. He returns to tracers because they keep the glow honest when images can be tricked. Globular clusters, if counted by colour, split into blue and red families whose spatial distributions diverge. Blue clusters often follow the intracluster light farther out, red ones hug the CD. Their velocities, when measured in sufficient numbers, form a two-component dispersion, one cooler, one hotter, a kinematic echo of a photometric decision. Planetary nebulae are fewer and dearer. Repeat the lesson where they can be found. Red giant branch stars, resolved only in nearer clusters, promise the same grammar, here if distance and instruments one day allow. In Abell, 5 counts are thin and uncertainties friendly, but what little is seen points the same way the maps do, a separate warm bath of stars shared throughout the core. A second lesser texture returns with population hints. The intracluster light often shows slightly lower metallicity than the CD's inner body, but higher than the far outskirts, consistent with a mix weighted towards stripped, intermediate mass satellites, rather than only dwarfs. Its A-element ratio leans modestly high, a memory that many of its stars formed in short early bursts before their parents were quenched by strangulation and ram pressure. The mix is not a riddle, it is a ledger, where the outskirts recorded one note and the core recorded another, and the sum plays between them. He places 3 soft ironies where they will not ask for more. Only took removing a galaxy's edges to reveal the cluster's shape more clearly than the galaxy ever could. Only required dissolving structure to build the best structure for maps an almost uniform glow that refuses to be anything but basin. Only needed the faintest component to carry most of the history of how things arrived, because the bright pieces forgot by staying whole. He keeps measurement's humility in view, because subtraction is a craft that can invent ghosts as well as remove them. Scattered light from bright stars makes false halos, unless the wings are measured to tens of arc minutes and modelled. Fringing and low-frequency flats inject slow waves into profiles. Galaxies at the frame's edge imitate envelopes if they are not masked deeply enough. Background galaxies masquerade as tidal features unless colours are used to separate them. Cross-checks imaging in different bands, nights and instruments. building a sky model from as many uncontaminated pixels as a field allows, testing profile breaks against kinematics where possible turn confidence into something earned rather than assumed. When done, the resulting slope slowly steepens beyond the galaxy's main body and slowly flattens into the cluster's bath, a geometry that repeats in system after system even as numbers vary. A quieter uncertainty sits in the outermost dark, and he lets it sit. How much of the intracluster light is truly ancient, cast off in the cluster's earliest assembly, versus how much is recent, built in the last few giga years by continuing infill? How much comes from pre-processing in groups that then fell intact? And whether the fraction grows steadily with time or stalls once the easy supply of loosely bound halos is gone. Observations of clusters at different redshifts suggest growth, but selection and surface brightness limits play against each other. Simulations predict steady increases with late-time spikes during major infall. The truth is, a band that clusters like Abell 85 help widen into a path. Dry observations resume their unhurried walk. They call the intracluster light diffuse, as if featureless, yet peel back a magnitude and shells appear. Peel back 2 and streams return, peel back 3, and the night asserts itself again and says enough. They call it contamination in some analyses, what must be removed to fit a galaxy. Yet here it is the object of interest, and the galaxy is the contaminant or reversal that shows how definitions carry intent. They call it universal, and in a way it is, yet each cluster's fraction, colour and shape differ by degrees that reflect histories too specific for a single curve. He settles the section by letting the component become a mood rather than a problem. Between galaxies in Abell 85, unbound stars drift like a low tide across shallow stone. Their light rises toward the CD and dims toward the rim. Their kinematics carry the cluster, not the city. Their chemistry speaks of early times tempered by long travel. The accepted fact remains where he placed it. The intracluster light is real faint and stronger toward the centre, a product of stripping, dry, merging and slow dissolution. The lesser detail keeps its seat where planetary nebulae or globular clusters can be counted. Their velocities and distributions confirm that this glow belongs to the cluster as a whole. The mystery stays proper boundaries between envelope and basin, the timing of growth and the exact mix of sources. The ironies settle unbothered. The lantern of gas still holds the room, the river of stars still moves across it, and the faintest light which almost is not carries the clearest map of how everything has come to be where it is without ever needing to raise its voice. He turns to the places where subtraction leaves shape, because in a cluster that prefers understatement, what remains after the best fit has tried its hardest is often the truest map. The accepted fact sits quietly in the centre surface brightness residuals and kinematic residuals differences between observed images or velocity fields, and their smooth models outline real structure in Holm 15A and its room, revealing faint shells, boxy or disky tendencies, off-axis twists and small anisotropy patterns that ordinary profiles and averages smooth away. The process is discipline rather than discovery. Build a photometric model that matches isophotes to high order. Convolve it with the point spread function. Subtract. Then do the same with a dynamical model that matches velocity dispersion and higher moments. Compare. Where both leave the same sign, there is furniture that smooth words could not keep. He keeps the craft slow so that patient differences can breathe. In light, the galaxy's faces first fit with ellipses, whose centres, ellipticities and position angles are allowed to wander with radius. Fourier terms, cosine and sine corrections catch tiny deviations from pure ellipses. A multi-component model, usually some combination of Sersic-like pieces, takes responsibility for the bulk. The PSF measured from stars to far wings is folded through the whole. What remains in the residual image is not noise writ large, it is geometry. The fit chose not to own a low-contrast plume stretched along a preferred direction. A minute boxiness in intermediate radii where radial orbits have left their square shoulders. A diffuse asymmetry that implies an approach lane long since quieted. In kinematics, integral field maps of mean velocity dispersion and the H3-H4 pair are fit by orbits within a trial mass model. Regularization keeps the library from memorizing fluctuations. Once a minimum lives in two, the residual fields observed minus model are inspected like a trace on a long exposure. Where residuals cluster in swathes rather than in specks, the model owns the wrong grammar. Where they ease into white noise, the grammar fits. A lesser-known detail rests beside these steps like a small compass in the photometric residuals. Weak systematic waves aligned with detector directions can masquerade as ripples unless they are defeated by dithering and flats built from night sky itself. In the kinematic residuals, spurious H4 structure can appear along slicer seams or across an integral field mosaic, unless line spread variations are mapped and tamed. It is in the nature of subtraction to invent ghosts. It is in the nature of residuals to ask whether those ghosts stand in the same place in both light and motion. He keeps the imagery elemental so errors can become anatomy. Residual light is silt that refuses to settle where the model told it to. Residual dispersion is an eddy that turns where the model's river wanted laminar flow. The combined map of leftovers is a relief, a low embossing of what the smooth face hides. In Holm 15a, the embossing is slight and gentle outer faintness that extends a little more on the side, where a filament likely delivers groups. A whisper of boxiness at tens of kiloparsecs, a symmetric calm in rotation with only a hint of twist, a dispersion field that rises toward the core in a way the model learns to match but never overdraws, H4 that says tangential bias in a tone so low that only stacked spaxels can hear it. A quiet mystery stays seated with unhurried grace. How to partition responsibility when a residual repeats. Does a low plume belong to a missing photometric component to an unhelpful PSF wing, or to an orbit family the library underpopulates? Does a small systematic indispersion arise from template mismatch from a master-like gradient left too simple, or from a dark halo slope held too stiff? Each knob can hide another's crime. Only when independent datasets, different bands, different instruments, different spectral regions leave the same trace does the imprint move from hypothesis to furniture. Dry observations place themselves like flat stones on the shallow floor. They call residuals errors as if apology yet errors in this craft are often the signals after the smoothest truths have been honoured. The apology is an atlas. They call the model good when H2 prefers it, yet good models still leave features. Goodness is not absence, but smallness with structure. They call subtraction dangerous, and they are right. Yet danger is the price of detail when difference holds the atlas's roads. He lets a gentle analogy breathe once and stop. The residual map is like the tide line on stone after a long, even sea. Smooth rock fitted by weather, faint salt rings where the model could not follow every cove, and in those rings the recent story of how the water leaned. He returns to the ledger of methods because residuals do not stay honest by wishing it. In light tests, rotate or flip the residuals to see whether instrument-fixed structures follow. In motion jackknife maps, fits repeated, leaving out small spatial bricks reveal whether a stubborn patch drives an unphysical pattern. Photometric residuals are compared across filters. If a plume is real, it persists in colour with only the gradients of an old population. If it is scattered light, it brightens with the bright star that caused it. If it is a background galaxy, it hardens or shows a core. Kinematic residuals are compared across template subsets. If H4 structure moves with template choice, it is not gravity. If it stays even when lines are fit in separate windows, it earns its keep. He places 3 soft ironies along the margin, where they will be found gently. Only took fitting a galaxy with exquisite care to discover that the smallest departures from the fit here say more about its history than the fit itself. Only required building a nearly perfect PSF to learn that its imperfect wings measured and subtracted reveal structures as faint as those wings would otherwise have invented. Only needed a model that explains almost everything to elevate the remainder from annoyance to anatomy. He lets the interplay between light residuals and orbit residuals return to the centre where grammar and gravity meet. A shallow core in light asked the orbit library to add tangential families to sustain high dispersion without hard spikes. If the library refuses residuals in H4, build a ring that the model cannot hide. If the library accepts and the black hole mass is free, the Q2 valley slides until the raised dispersion is matched and H4 calms. At larger radii, if photometric residuals show a faint extra skin aligned with a preferred direction and kinematic residuals show a slightly hotter dispersion along the same axis, the two together say accretion lane without a headline. Where light shows a tiny asymmetry but motion stays bland, the asymmetry may be a last plume of a dissolved satellite photometric alone. Where motion shows a small coherent twist and light stays featureless. The twist may be future residual light's preface, a kinematic foreshadowing of a structure still too faint to see. The method lets leftovers confer across senses. A lesser-known detail sets its foot down gently with population's line index residuals. Differences between measured absorption strengths and those predicted by a smooth age metallicity A model sometimes reveal small patches where metallicity dips or A enhancement tilts at fixed radius, likely the faded imprint of an accreted core. These chemical leftovers do not always align with photometric or kinematic ones, but when they do, 3 maps agree that the history was local here before it became averaged. He keeps the cluster's weather in view, because residuals live in the gas too. After subtracting an azimuth, Ali averaged X-ray model, edges brighten where cold fronts persist and thin arcs sharpen where a weak shock once passed. Entropy residuals catch sloshings spiral more plainly than raw temperatures. Pressure residuals smoother by right pick out cavities when feedback has been kind enough to leave any. In Abell 85 the imprints are modest, yet they repeat across methods enough to be furniture one arc where density steps down and temperature up, one curve where cooler gas rides inside warmer, a central cup where metallicity lingers higher than Fitz would have dared to predict before resonance scattering was corrected. Dry observations resume their patient walk. They call a residual an overfit's revenge, yet overfitting is kept back by cross-validation and regularization, and what remains after such restraint is less revenge than reward. They call faint structure marginal, yet marginal in one band that returns in another, becomes medium in the sum. They call the process subjective, and it is, but subjectivity here is a tested habit. Repeatability across methods qualifies each subject into a citizen. He allows one more gentle analogy and lets it go. Residuals are like the brush strokes a restorer reveals under varnish. The painting remains the same scene, but the artist's hand, once seen, cannot be unseen, and the line of a hill or the tilt of a roof becomes intention rather than result. He returns to the central scale that started this sequence, because numbers need not be left behind when they stop being stars. In Holm 15, the smallest photometric residuals and the lowest amplitude kinematic leftovers are consistent with a long-ago sequence of mostly dry mergers whose debris has nearly dissolved, leaving only a slight preference for certain angles and a core that is shallow enough to be read 2 ways. The orbit library's residuals prefer tangential bias within the inner kiloparsec. The black hole mass inferred sites inside a range that different priors can shift but not beyond the class. The X-ray residuals show no fresh-loud cavities, only the small grammar of slosh and step. 3 final ironies lie down where they will not call attention. Only took mapping what the model could not explain to explain what the model could not map. Only required refining the background, the night itself, to higher precision than the object's average brightness to see the object's faintest truth. Only needed subtraction, a word that sounds like loss, to turn into the most additive act in the script. He lets the section end without verdict. The accepted fact has done its work. Residuals in light and in kinematics are where Abell 85 and Holm 15A keep their subtlest records contours of what assembling and aging have left. The lesser detail keeps its place. Instrument-fixed ghosts must be tamed, so that what remains repeats across filters and fields. The mystery stays modest, apportioning mist light among PSF components and orbit families, apportioning mist motion among templates, ML gradients and halo shape. The ironies rest. In the quiet interior of a cool core cluster, the atlas of difference continues to draw thin lines where smooth maps stop, and those lines together are the room's handwriting. He lets hunger be measured by quiet instead of flame, because in Holm 15A the largest engine in the room eats slowly enough that heat leaves almost no handwriting. The accepted fact rests without decoration. The nucleus is sub-Eddington. By orders of magnitude, its accretion rate inferred from weak radio and faint or often undetected X-ray, point emission falls well below the level that would produce bright quasar light. What feedback exists is gentle, a thermostat more than a furnace, consistent with a hot gas-poor core in a cool core cluster. The broad CD envelope offers old stars but little cold fuel. The intra-cluster medium nearby is dense enough to shine, and yet hot enough that it resists condensing. The black hole therefore sips from a thin, warm bath, rather than from a cold river. In such conditions, radiatively inefficient flows are the natural language. Advection-dominated or more general low-efficiency, thick, hot accretion, where most of the energy rides inward or leaks into outflows, rather than emerging as light. A lesser-known detail sits beside the ledger, like a small instrument on a quiet stage. The Bondi radius where the hole's pull overcomes the hot gas's pressure support is tiny compared to the sphere of influence measured in parsecs or tens of parsecs for typical inner densities and temperatures. So even if the gas were available, the region that feeds by quasi-spherical drift lives far inside any present map. What observers weigh instead are small radio knots or limits on a point like X-ray source, and translate those into appetites with models that prefer humility over spectacle. He keeps the physics unhurried so the silence can be heard properly. In a hot core, electrons and ions share heat poorly. The plasma is diluted the mean free path long compared to small eddies, and transport is steered by the magnetic fields. A radiatively inefficient flow, if present, carries most of its energy inward, without radiating with luminosity, scaling roughly as the square of accretion rate rather than linearly. Jets, if launched, can carry mechanical power vastly larger than the meagre light they produce. But here, if jets exist at all, they are modest, short, perhaps intermittent, aging quickly in the cluster's gentle pressure, and leaving no grand radio lobes, only hints that fade with frequency as electrons lose energy by synchrotron cooling. He lets one gentle analogy breathe once, and stop. The nucleus is like a great millstone turning in a season of drought, heavy and capable, yet fed by a trickle. The wheel turns, the machinery hums, and only a slight warmth in the stone's face proves work is done. The quiet mystery remains modest and useful. How the heating budget closes without obvious cavities or long jets. What share comes from weak frequent puffs that stir sound waves into the core? What share trickles in by conduction from warmer layers? What share arrives when sloshing brings a cooler tongue inward that mixes and then vanishes? In some clusters, the arithmetic is loud cavities, shocks, ripples. Here it is a ledger of constraint, no catastrophic cooling, no blaze of a central quasar, metallicity peaks, preserved cold fronts intact. Each line item says enough heat often enough without pointing to a single starring mechanism. Dry observations step down like flat stones across a low stream. They call the hole starved, yet starved here means accreting at a rate that would still outrun any human engine if we could weigh it by kilograms per second. They call the core quiet, yet the absence of catastrophe is a measured equilibrium, not a lack of phenomena. Cooling times, entropy flaws, and modest pressure ripples all testify that something small but steady keeps pace. They call the feedback weak, yet weak repeated many times across millions of years balances a budget that flamboyance would overshoot. He keeps the imagery elemental, so the arithmetic can breathe. Gas is dusk trapped by pressure. Light is the thin record of work, almost all of it mechanical and hidden. The field is a grain that directs transport and stifles conduction where draped. The black hole is the weight at the bottom of a bowl, whose depth is mostly set by stars and dark matter. The bowl does not need to boil for the soup to stay warm. It only needs the occasional stir. He touches measures because measures, even when small, keep gentleness grounded. Central X-ray limits permit only a faint point source. Radio images, when stacked, reveal compact emission at a level that marks a nucleus alive but not loud. The ratio of radio to X-ray is consistent with the low Eddington jet-dominated or outflow influence mode, where mechanical work can exceed radiative output by orders of magnitude. Yet any bubbles inflated must be small enough to have blended into pressure maps, or old enough to have drifted and mixed. If cavities exist, they hide like dim lanterns behind the cool front's glass, less an event, a continuation. A quieter, precise detail settles near the page's edge. In such regimes, variability can be the loudest thing a quiet core does hour-to-day radio flicker, from compact regions or year-scale changes in a faint X-ray point. But at this distance, and with this nucleus so dim catching flicker, requires patience that maps rarely get. The likely truth is steady faintness, and that truth has more to say about fuel than about spin. Spin itself takes its seat and says little. An ultramassive black hole could in principle hold high spin and launch efficient jets. It could also be slowly rotating after a history of random dry mergers that cancel angular momentum. In a gas-poor environment, neither case leaves an outsized radio signature by necessity. The cluster's thermostat cares about delivered power, not about how the turbine is geared. Dry observations continue their walk. They call non-detection a lack of evidence, yet for budgets it is often the strongest statement: no large cavities, no strong shocks, no blue starburst, each a number with weight. They call accretion models speculative, yet in the low Eddington regime, many flows converge on the same behaviour: dim, thick, mechanically capable, and radiatively poor. They call such nuclei dead, yet they are only resting between meals.